Good evening to all. My name is K. Bhuvaneshwari Bai. My roll number is 461. Today my topic is intrinsic and extrinsic semiconductor in electronic devices and circuits. Introduction to semiconductor. What is meant by semiconductor? Semiconductors are the materials with electronic conductivity between conductors and insulators. They are essential component in electronic devices and circuits. If the semiconductors are two types, one is intrinsic semiconductor and another one is extrinsic semiconductor. We have to discuss, let us one by one. Intrinsic semiconductor. What is meant by intrinsic semiconductor? An intrinsic semiconductor is a pure form of semiconductor material without adding any impurity. Its electrical properties are determined by the material, its own atom. If the conductivity of intrinsic semiconductor increases with a temperature, here we have to see the intrinsic semiconductor diagram and also see the energy band diagram. Characteristics of intrinsic semiconductors. If the intrinsic semiconductors have equal number of electrons and holes maintaining charge neutrality. The common example of intrinsic semiconductors like silicon and germanium. Here the silicon has 4 valency electrons. Here we have to see the intrinsic semiconductor diagram with a silicon. They are primarily used as a baseline for the understanding doping and extrinsic properties. What is meant by an extrinsic semiconductor? An extrinsic semiconductor is a doped with the impurities and to modify its electrical properties. We have to see the extrinsic semiconductor diagram. It means the extrinsic semiconductor is doped with a impurity. The doping introduced the free charge carriers, either electrons or holes, into the material. Here we have to discuss about N-type and P-type semiconductor. That N-type semiconductor are doped with elements that add extra electrons as charge carriers. Here P-type semiconductors are doped with elements that creates holes acting as a positive charge carriers. The combination of N-type and P-type materials form the basis of many electron devices. Here we have to see the P-type and N-type semiconductor diagrams. Example of N-type semiconductor, arsenic. If example of P-type semiconductor as boron. Doping process and its impacts. The doping involves adding a small amount of impurity atoms to the semiconductor material. If the electrical conductivity and enables the fabrication of various electronic components. Precise control of a doping level is a criteria of a device performance. Applications of intrinsic and extrinsic semiconductors. If the intrinsic semiconductors are used in research and baseline materials for doping. Extrinsic semiconductors are widely used in diodes, transistors, and integrated circuits. If both are essential in creating modern electronic and photoelectric electronic devices. Comparison of intrinsic and extrinsic semiconductor. The intrinsic semiconductors are pure, less conductive, temperature dependent, and the extrinsic semiconductor are doped, highly conductive, tailored for specific functions. If both play a complementary role in semiconductor technology. Conclusion. Understanding the intrinsic and extrinsic semiconductor is a fundamental to modern electronics. Emerging materials are doping, and doping methods will shape the future of semiconductor technology. Advancement in development techniques continue to improve the device efficiency and functionality. Thank you.